Here we go again, a review over the digestive system, part 3. So, not a lesson, just a review of things we've talked about before. And let's just get started right here with the idea of what are the sphincters that are involved. The sphincters are involved in creating compartments where you can change the chemistry and control the digestion. It begins with the orbicularis oris, which is a skeletal muscle, and so therefore there is direct conscious control if you're thinking about it. This is one that closes your mouth so that when you swallow, the food doesn't fly out. Little babies have to learn how to use this, otherwise every time they swallow, things fall out of their face. It's part of that game we talked about in class. Here's the upper esophageal sphincter, which is skeletal muscle, and it separates the pharynx from the esophagus. The orbicularis oris, by the way, separated the outside environment from the mouth cavity. The upper esophageal sphincter is skeletal muscle. Some people have control over it. More often than not, it's just one of those things that does its job. You may not have any direct conscious control over that you know of. Moving on down to the lower esophageal sphincter, also known as the cardiac sphincter, also known as the gastroesophageal sphincter. This thing right here is made out of smooth muscle, so again, you have no conscious control over it. It separates the esophagus from the stomach. The stomach itself is particularly acid, so this thing right here separates the delicate inner lining of the esophagus from this rough inner lining of the stomach. And any kind of leakage right here can lead to heartburn or lead to esophageal ulcers. GERD, G-E-R-D, stands for gastroesophageal reflux disease, in which this thing's a little bit leaky and some of this chyme material can go backwards. Okay, by the way, as we said before, the stuff outside your face is called food. You put it inside your mouth, you chew it up, you form it into pellets. The pellet is called a bolus. That's what you swallow down to your stomach. But then inside your stomach, you add gastric juice and you make it soupy and you break it apart. Now you call it chyme. And we mentioned that chyme inside the body is what you would call vomit outside the body. So when you throw up, it's chyme time. All right. Very, very acidic right here, a pH of around 3. Moving down through the pyloric sphincter, we're now inside the small intestine. The pyloric sphincter is made of smooth muscle, and again, it separates the stomach from the small intestine. Inside the small intestine, you have to begin to buffer or neutralize this acetic chyme from the stomach. And so therefore you add pancreatic juice and intestinal juice. Both of these things contain sodium bicarbonate, a base, and they can slowly begin to buffer or neutralize the acids that are coming down from the stomach. And the material moves from the stomach into the small intestine in very small amounts, very, very slowly, approximately 3 milliliters 3 times per minute. So therefore it takes quite a long time to empty the stomach out normally. Again, the food material that's inside the small intestine is called chyme. Next valve right here is called the Ileocecal Valve. It's also smooth muscle, and it separates the small intestine from the large intestine. Now, this is not just a ring or sphincter of smooth muscle. It also has 2 flap-like valves on it to help the material move from the small intestine to the large intestine and hopefully not back up. The reason behind that is chyme is relatively sterile, but feces does have a lot of bacteria inside, for example, E. coli. And at this point right here, we might say that the digestion that you're responsible for pretty much occurs all the way to this point right here. The digestion, that chemical digestion that occurs inside the large intestine is pretty much due to the bacteria that are found inside the lumen of the large intestine. So there are no major digestive enzymes that are produced inside the large intestine. The E. coli, however, and other bacteria have the ability to break down some of the residual materials that you couldn't, and very often it releases vitamin K and some B vitamins, which your body can absorb. Also, you were reabsorbing a lot of fluids in the lower section of the small intestine, and here again, you can reabsorb a lot of materials. Approximately 40% of the weight of dry feces is bacteria. So a good bit of the bulk of feces is bacteria that you grew inside your large intestine lumen. This volume slows down the movement of the fluid and that allows time for you to reclaim some of the fluids that you invested in this process right here. Again, remember, you invested saliva, gastric juice, pancreatic juice, and intestinal juice, and somewhere around 7, 8, 9 liters of fluids were invested in this process right here, along with the beverage that you ingested. There we go. Anyway, and you need to reclaim that fluid down here. The last two sphincters are the internal anal sphincter and the external anal sphincter. They both separate the lumen of the large intestine from the external environment. The internal anal sphincter is smooth muscle. The external anal sphincter is skeletal muscle. The internal anal sphincter is pretty much under the control of the spinal cord. And so when the volume inside the lumen of the large intestine is large enough, signal goes to the small intestine sends a signal to the internal anal sphincter to relax, and you'll have a bowel movement. However, the external anal sphincter has the ability to clamp down and prevent that movement from happening. So when a signal goes to your spinal cord, another signal goes up towards your brain, and your brain has an opportunity to send a signal down to your external sphincter saying, no, not now. And you have a little bit of a competition, and hopefully you win. By the way, children are not really connected to their external anal sphincter until they're about 2 years old. So trying to toilet train a child before they're 2 years old is a little bit awkward because the child may not have any control whatsoever, even though they want to do what you want them to do. Okay, a little bit more about the internal environment of these sections. Again, the pH of the materials inside the mouth, pharynx, and esophagus is around 6. It's variable, but it's slightly acid. Inside your stomach, because of hydrochloric acid, it's around 3 to 4, very acid. And inside the lumen of the small intestine, it's closer to 7 to 8, so slightly alkaline. And because there's these distinctions right here when it comes to the pH, that means that in enzymes that may be active in the mouth aren't active in the stomach, and something active in the stomach wouldn't be active inside the small intestine. So in the next little review right here, we're going to talk about the only major digestive enzyme that's available in the mouth, salivary amylase, in its proper environment. The only major digestive enzyme inside the stomach, and that's gastric pepsin in its very acid environment. And then the rest of these on this abbreviated list are working inside the small intestine. Some in the lumen and some up against the brush border, the edge of the epithelium, but all these things functioning in a slightly alkaline environment. We're going to go through these things, how they work in general, and review as we did right here, as we did in class, and that's the next one.